Hello friends, myself Santosh Vishnupurkar. I am from Nasik city, working as assistant professor in IT department, KK Wag Institute, Nasik. Myself research scholar from Matoshi College of Engineering, Research Center, Eklara. So currently pursuing PhD under wireless network. So topic for my presentation is wireless network. Now you might be wonder why to choose this topic and what will be the scope for this wireless network subject or this course. This wireless network, as we normally knowing, wireless communication involves the transmission of information over a distance without help of wires, cables. Wireless communication is a broad term that incorporates all procedure and forms of connecting and communicating two or more devices. So that's why this wireless network I chose this particular topic for exploring purpose. The evolution of this wireless technology seems to be somewhat in a great over a great extent. Many advancement, many features those are seems to be incorporated with the latest trends, with the latest market. The transmitted distance can be anywhere between few meters to some hundreds of kilometers or more than that. Like for example, television, remote control, that radio communication or that satellite communication or mobile communication. Wireless communication can be with a cellular telephony, wireless access to the internet, wireless home networking, and thereupon or there further. Other examples you might be considered like radio wireless technology that include GPS or some it is from the category of satellite network, wireless computer, that keyboard, headset, headphone, radio receiver, satellite television, broadcast television, cordless telephone. So this can be the wireless network, or with the help of this there can be the wireless network. There are some of the specific advantages from this wireless network point of view. Wireless communication involves transfer of information without any physical contact. So it is not like currently we are suffering from COVID contact. So contactless communication. So this is apart from this would be that not dependent on the any distance. So there is no bar about distance. Wireless communication has several advantages like cost effectiveness, that instead of wired and that bulky structure and which is somewhat not supporting changing technology, changing topology, so physical infrastructure and its maintenance seems to be somewhat reduced, so hence cost is reduced. Flexibility, wireless communication enables people to communicate regardless of their location, regardless of their intelligence, means you can communicate over a distance with a small device. So this can be the one of the point from wireless network point of view. You can consider convenience of wireless network. Wireless devices like mobile phone are quite simple and can use anybody that with a little knowledge of that particular device handling. So internet, Wi-Fi that can be accessed by that particular body while it is on a move or while in a pedestrian condition. Speed improvement with the wireless technology seems to be observed, like after that TDMA, then with your T1, T2, T3, T4, T5 carriers. So there is some large improvement seems to be observed from last some quite 2 decades. Improvement can also be formed in the form of speed of communication. So accessibility very much improved in accuracy and speed. And again, constant connectivity. So constant connectivity without handoff, without dropping the call, without any disturbance, that seems to be observed with this wireless network. So that's why this wireless network mostly chosen by most of the designer, most of the engineer, most of the people for their application, for their usefulness, and for sharing their information for a remote distance. So remote location handling, remote distance, remote information sharing, that can be the options from this wireless network point of view. So that's why I am exploring this particular topic for you people and that you need not to have some great knowledge for this particular subject. You just need some basics of what do mean by wireless and some basic from electronic background. So the people from computer engineering, IT, electronics, electrical can contribute or can participate for this subject, or you can have some great awareness of this wireless network, or you can explore wireless network to a great extent with me for this upcoming course or upcoming content of this particular course. Thank you for today's session. Hello friends. So topic for the detailing is wireless network. So under wireless network we have different points. We can have first wireless LAN and wireless WAN. So wireless network, this particular broad umbrella is basically divided in two sections. The first one is called WLAN and second one is called WWAN. So wireless LAN. This wireless LAN can be standardized, or its features or its guideline is declared by the IEEE 802.11 standard. IEEE 802.11 standard. So under this IEEE 802.11 standard, that committee member or the designer or the organization, they decided certain set of rules for WLAN. This WLAN can be possible with the help of radio waves, and this with the help of infrared waves, radio waves and infrared waves. So basically WLAN can be categorized like your radio wave based WLAN and infrared wave based WLAN, like in the form of photo detector and all that. So according to that, this WLAN. So WLAN itself is nothing but 802.11. So this is the first one that we will try to explain. Then under WLAN there is another technology, or you can say another flavor of WLAN is HyperLAN, high performance LAN. Why to use this high performance LAN? This high performance LAN normally utilized in the condition when you are over the network, over the wireless network, when somebody would like to communicate and that particular fellow would like to transfer his or her information with some higher speed, in that case, that normally data that will be transferred over the radio channel or that over the wireless channel is in the form of TDMA frame. The data normally transferred in the form of TDMA frame. But while this data is transferred over in the form of TDMA frame, so that TDMA frame, each slot is allocated for the user. Or the subscriber, so that number of customers, they can send their information in the appropriate slot of that TDMA frame, and that frame is somewhat forwarded from the mobile station to nearby base station or nearby mobile tower, and thereafter it will be transferred to another mobile. So instead of doing all that, or instead of performing this kind of activity, you can allocate that whatever the number of time slot for a single user, so that single user can transfer his information with immediate effect, immediately over the network. So there is no botheration for the particular customer to transfer information or wait for his turn to transfer his information in that standardized time slot. So that is the high performance LAN. So your data rate or your communication rate seems to be very, very high compared with the other one or with the available one. The goal of HyperLAN was normally that at that time is to support high data rate, higher than the 802.11. That's why I am just listing it in after WLAN. And it is according to that European Telecommunication Standard, that institute, who decided about this HyperLAN policy and HyperLAN guideline. So no doubt in the concern with the IEEE organization. Again, this HyperLAN, the standard covers physical and media access control, part of the data link layer. So basically, what do you mean by data link layer? It is the layer it is a part of computer network. This data link layer accommodate, which is somewhat responsible for forming a frame, for creating data in the form of packet, and to check address, to add some error correction or error control bit. So that data communication seems to be very effective, errorless, or that without any loss of data. So that normally controlled by the help of data link layer, and data link layer internally divided into two parts. One is called media access control and logic link control. This media access control is normally for the purpose of means the number of session over the network or number of user over the network, who going to serve first or who going to serve with the immediate effect. So that can be very well analyzed, very well find by the help of media access control layer. Means there are multiple mobile in the network, so who get the access for that particular network. Apart from that, there are multiple mobile, those who would like to communicate with a different. So there are multiple information, those are crunched in a single package or with a single section, and that will be communicated over the terminating devices or from the terminating device to multiple devices, vice versa. So for that, logic link control layer. So there are two layers, those are available, and so these two layers, those are also been considered in case of hyperLAN for improving the data rate, because both are responsible equally for improving the data rate. As TDMA frame, all slots those are allocated for a single user, or that multiple users they can share interchangeably for that particular time slot. So this is hyperLAN. Then there is the most promising technology who are replacing that your infrared wireless network or infrared WLAN. So Bluetooth IEEE also contribute for these 802.15 standard. It is 802.15 standard. So this 802.15 standard, with the inclusion of this Bluetooth, electronic devices or electronic communication network get some another flavor, some extra flavor. With these, that you found that most of the electronic devices, those are coming with Bluetooth provision for communication, for data transmission, data communication. So data communication seems to be very fast, or that connectivity of personal network or personal area network, personal network formation from the user seems to be very high with this Bluetooth technology. It is normally under the head of personal area network, PAN, personal area network standard. This Bluetooth, it uses Bluetooth, wireless LAN, hyperLAN, all these buddies, they are using ISM band, industry scientific medical band, industry scientific medical band. There are different ranges for this industry scientific medical band. These different ranges are like you can have 2.40 to 2.480, that particular band for its application. Then there can be 5.4 to 5.8, 5.138, 5.150, 5.280, 5.95, 433 megahertz. Then like this, there are somewhat 6 to 7 different bands, those are available, like 13.53 megahertz. Then there is the 902 megahertz, 2.4 gigahertz, 5.75 gigahertz. So there are different ranges for the communication for this ISM band. ISM band, industry scientific medical band. It doesn't mean that you are entirely using this particular band for your wireless communication or this Wi-Fi, wireless fidelity network. Means in this case, what is happen? This particular spectrum is utilized by medical devices, some electronic devices, as well that some your communicating devices. So again, it is unlicensed band. So that's why it seems to be most demanding band for the proprietary application. Then after that, there is another section, wireless broadband access, WiMAX. So which seems to be the last mile replacement technology in the form of wireless network, and this is called wireless broadband access. This wireless broadband access support for the, it is for the view of mobile communication that can be communicated with the Wi-Fi. So you can have that like packet transmission with a fast rate, acknowledgement, and without the botheration of that error correction or error control. Means frame loss, handoff, that seems to be somewhat very improved way in this case with the WiMAX. So WiMAX is nothing but the replacement for that last mile digital subscriber line, And with the inclusion of this WiMAX, your wireless network seems to be very, very effective, and with the help of this standard, with the help of this technology. Then after that there is the RFID, radio frequency identification. Again it is again utilizing the same frequency band and all that, but it will be working on the principle of mutual induction. By the help of mutual induction and by the help of some energy supply, so that you can generate the radio field. So that this RFID getting popular day by day. RFID normally utilized in most of the country in case of library or in case of parcel identification. This RFID, you might be heard this word radio frequency identification, or you might be coming across the term RFID tag. So there is a reader and there is a transmitter. So again this RFID available in different flavors. We are going to see that in detail. Again after this there is another section that will be started. Basically wireless network divided in two parts: WLAN, WWAN. One is for small network, low power supply network, low power net devices, small network, less QoS, less security. For WLAN, great coverage, great security, better QoS compared with the WLAN. So wide area network and local area network. So those can be somewhat the part of this one. Then WLAN, under this heading, obviously satellite network, artificial satellite, not natural satellite network. And one more promising and the part of life is mobile communication. So under this heading we are going to see what is satellite network, how it will be effective, what is the significance of this satellite network in our day-to-day life. Same way in case of mobile communication, what will be our achievement with the help of mobile communication, with the help of this wireless network. So who are the designer of this wireless network? So those are like thanks to the designer or that inventor for this mobile communication. So 1G, 2G, 3G, 4G, 5G, and what will be the difference in that, and what will be their achievement in terms of data rate, in terms of technology, that we are going to see in a brief. So this is all about this wireless network outline, you can say outline. So thanks. If you have any question, do reply me. Thanks. Hello friends. So topic is WLAN, wireless LAN. Wireless LAN. So you might be come across the term LAN, like LAN, local area network. WLAN, it is a wireless local area network. LAN, it can be wired as well as wireless LAN, normal LAN. WLAN, it is wireless. You can treat normal LAN, term LAN, covers large area, buildings like that. But WLAN covers region of buildings and offices, but better connectivity, interconnectivity in between that. LAN connections normally less expensive as the costing of wireless devices with accuracy and with their quality of service. Devices seems to be somewhat costly, but initial cost seems to be the lifelong merits or lifelong outcome, lifelong advantage. So WLAN seems to be costing seems to be somewhat high. Then complexity for a normal LAN is somewhat initially with a router, with the switches, with the wires and all that. So for a flexible design point of view, LAN seems to be cumbersome, but WLAN seems to be fast, easy. Normal LAN provides somewhat better performance. Your WLAN might be suffering with a little bit performance. Why? Because there is a security issue, because there is some as WLAN utilizes the frequency band of ISM. So ISM band, so there can be co-channel interference that might be observed with a microwave, with on the same frequency. If another party is somewhat communicating, so that will be the issue with the performance. Again, in case of LAN, mobility seems to be somewhat limited. but wireless LAN support better mobility. So that is somewhat LAN and WLAN. Now we talk about. So objective for this particular topic is understand necessity and constraint of wireless LAN. So why wireless LAN is demanding? So that is the answer. Because it is without cable and without that infrastructure, tedious work and all that. So wireless LAN provides solution, cost effective solution, ease of access, ease of deployment, ease of handling. So all that ease is good on all that. Application normally in schools, railway station, airports. You can't treat this as a like in case of in case of office, in case of colleges, college campus, hostel building. So you might be getting this WLAN, or most of the that organization or most of the educational institute, they are going for some higher grading. They are normally having this WLAN feature or that WLAN implementation at their premises. So you people by your naked eye you can observe this WLAN. Advantages of this WLAN or wireless LAN is as explained, but disadvantages, there are some of the disadvantages for this WLAN point of view. There are some of the disadvantages from this WLAN, and disadvantages like that costly, cost effective, low bandwidth. Why? As it is the ISM band, as it is the using ISM band, and ISM band is the unlicensed band, mainly ISM band, unlicensed band. As it is the unlicensed band, so there is a problem with this unlicensed band. The problem is that the bandwidth or the band of this ISM section is considered to be very small, like 1 megahertz bandwidth, like less than that. So normally the bandwidth supported by this WLAN is seems to be somewhat limited or seems to be somewhat small, and that's why large number of customers cannot be accommodated in this case. So that is the issue, low bandwidth, devices costing. Then again it is somewhat, there is a while it is initially deployed, so there is a some interface, as far as interface with a mobile technology, means you can place a call on from your mobile on your Wi-Fi network, or from Wi-Fi network on a mobile, that communication. So in that case this seems to be somewhat tedious one, means in that case you need to know what are the different limitation, different frequency band, and their interface, wireless interface seems to be somewhat improved. So that work is somewhat currently going on. So this is somewhat related with the WLAN. Apart from this, if you are interested in any that disadvantages, or you can say demerits, this file sharing and the transfer of information on Wi-Fi, that Wi-Fi wireless fidelity seems to be somewhat very small or very low compared with the normal network. Then it can be abstracted by every that household items, or most of the household item, walls, ceilings, etc. It is a less secure, no security that will be supported in this case. So these are some of the problems, security. Apart from that, good things from that WLAN story. So this is all about WLAN introduction, or wireless LAN introduction, or Wi-Fi introduction. So mostly you can use this for your application. Hello friends. So another players from WLAN group, infrared WLAN. You can say WLAN. So it uses infrared, the band which is somewhat at the lower end of visible spectrum, infrared light. So this IR diode is nothing but IR enabled devices, somewhat known as IRDA devices, because they are emitting light, but this light is somewhat not observed by human eyes. It passes through a lens and focus into a beam of IR. The beam source is rapidly switched on and off for data encoding or for decoding in that condition. This IR beam data is received by an IRDA device only. So photo detector, opto coupler, those are normally utilized with a silicon photo detector, you can say this way. This receiver converts IR beam into an electrical current for processing, because IR transition more slowly from ambient light than from a rapidly pulsating IRDA signal. The silicon photodiode can filter out the IRDA signal from ambient IR, but this IR is highly affected by sunlight. So this infrared, again in this case, it normally utilize that point to point or line of sight and non-line of sight. So IRDA can be available in two flavors. You can see this. You can see this way. So IRDA, so it is point to point, or that you can say in a non-line of sight, point to point in non-line of sight. So this can be the two variant in case of IRDA or this IRDA connection. After that, this IRDA diodes, while they are emitting the light, this diffuse light, so multiple reflection can be possible through walls, through furniture. Means if you are having your remote control and if you are sitting on a transparent floor, so through that floor you can control your television by television remote. So that is somewhat the reflection that can be possible with IRD, with the IRD. See, infrared is an invisible band of radiation that exists at lower end of visible electromagnetic spectrum. There are two types for this infrared: direct beam or line of sight, and diffuse beam uses reflected rays. The direct beam WLAN offers faster data rate, while diffuse beam technology achieves lower data rate, 1 to 2 Mbps, that communication data range. The advantage of using this technology is that there are no government regulation on its use, and also it is immune to electromagnetic and radio frequency interference. So this is somewhat quite good point regarding of IRDA compared with the normal radio waves WLAN, normal radio waves WLAN. But the disadvantage, with some cost. What is that cost? Disadvantage is that it is a short range technology, 50 feet, 100 feet, that is the normal. Also it requires line of sight. The signal get affected by solid objects like door, walls, etc. The signal get affected by light in presence, that like sunlight, fluorescent bulb. This can be avoided using high signal power and an optimal bandwidth filter. This signal can also be affected by fog, dirt, ice, snow. So these are some of the points with respect to IRDA. But this IRDA, the entire all this lacuna, all this limitation that can be overcome by the use of simple shielding technique. But some of the time that is like person who work as a guard, that can be work as a like theft. So that way the shielding can be on the reverse side work as a absorber, light absorber. So shield may absorb IR light some of the time, and obviously ISM, so low bandwidth, this low bandwidth. And again this IRDA, this normally having some getting some little bit popular, not some huge popularity for this, because this interface available everywhere in most of the case. So this the frequency range for this IRDA can be in the range of 800 megahertz section or power level 1 to 2 watt. So that can be somewhat the option for this IRD. And with the help of this infrared light, you can form a small network and you can communicate, or you can send the data here and there by the help of this IRD. So this can be the player, but it is not quite competitor compared with the WLAN, and on the same base in case of Bluetooth. So Bluetooth seems to be more popular compared with this. If you are checking this IRDA and this IRDA versus radio transmission comparison, so main advantage of infrared is it's simple and extremely cheap senders and receiver. No license are required. PDA laptop, notebook and electrical devices cannot interfere with infrared. So that is the point for that advantage of infrared. But infrared uses diffuse light, that directed line of sight, again that sender and receiver. So these are some of the points. But disadvantages: infrared transmission are lower bandwidth compared with other LAN technology. Limited transfer rate 115 kbps. We know that even 4 Mbps is not particularly high data rate. Infrared cannot penetrate walls. Typically good transmission quality and high data rates. That is direct connection is somewhat needed in case of infrared. On the reverse side, this radio transmission with a wired WLAN seems to be more effective compared with this IRD. So this is all about for IRDA network, or you can say wireless network or WLAN, other player of WLAN. So thanks for this session. Hello friends. Topic: HyperLAN under the head of wireless network, WLAN network. HyperLAN seems to be the somewhat good condition, the promising technology as far as networking is concerned, or wireless networking or wireless communication network is concerned. This HyperLAN, high performance radio LAN, is a WLAN standard. It is an European alternative for the IEEE 802.11 standard, which is international organization. The ETSI, this somewhat defined by this define the project like brand, broadband radio access network. The HyperLAN has 4 different variants: HyperLAN 1, 2, 1, etc. This HyperLAN was the mainly designed for the goal of high data rate, higher than that opposite party, IEEE 802.11. The standard covers physical layer and media access layer, and there is a new sub layer that will be added along with physical that data link layer and media access layer and data link layer. So in data link layer another layer is added, control access layer. So control access layer and that sub layer, so which is somewhat accomplishing better connectivity dependent on the usage of channel, usage on demand of the user, and the priority of the request from the user. Primitive and non-primitive, that multiple access that can be supported by this HyperLAN. So with a MAC layer, that routing, security and power saving are being provided by the help of this. Natural data transfer for the upper and that lower section, that seems to be improved with the help of this MAC enable technology. This HyperLAN normally utilize for the data rate more than 25 Mbps to up to 100 of Mbps, more than 50 meter. In a mobility condition, latency that can be more than for 10 meter per second or up to 50 meter per second. Normally 25 audio signals, audio channels that can be combined in a single TDMA frame, and you can communicate more than 30 to 50 Mbps data that's supported, and packet oriented topology that being supported by this HyperLAN. It supports asynchronous connection. So you can have that like acknowledgement. So for every packet there is acknowledgement, and there has been some slow data rate that's been supported according to this technology point of view. Better handoff that will be supported. Then security and throughput being high in case of this section. Obviously scalability, as there are multiple channels, those can be accommodated. Scalability, deployment, ease of deployment that will be supported. So asynchronous and synchronous topic, no doubt asynchronous that will be mentioned, synchronous with high data rate that will be supported. But in this case, while For power consumption, it specific wake up and that sleep, that pattern that will be helping for power saving with this hyperlan kind of device. This ATM and IP network, it can be utilized this with the support of this hyperlan. And that UMTS backbone network that been utilized this hyperlan. 5 gigahertz band normally utilized in case of this hyperlan. 54 Mbps data that been supported by this hyperlan. So quality of services like data, sound, video transmission and quality of reception that been improved with the help of hyperlan technology. That security, as far as security is concerned, DES, triple DES algorithm that been utilized. And as far as physical data rate or physical layer point is concerned, BPSK, QPSK, 64 QM or more than that been utilized, and OFDM also been incorporated in some of the conditions. So this is the link, or that will be some of the time this hyperlan can be termed as hyperlink, and that support up to 155 Mbps data rate. So this hyperlan seems to be somewhat great player compared with the mobile and your Wi-Fi if you are talking for small range communication. So this is somewhat brief about hyperlan and its detailing. If any question you do ask as per your requirement. Hello friends, topic Bluetooth, title under wireless network, technology, promising technology, replacement for IRD or replacement of IRD. Bluetooth getting more popular day by day, as mostly you come across the system, Bluetooth speaker, Bluetooth headphone, earpiece. So most of the trends shifting over the Bluetooth as far as networking point of view is concerned. So what is Bluetooth? So we are going to see. So in this lecture we are going to see what need of Bluetooth and its constant. So Bluetooth is a short range wireless technology, standard use for exchanging data between fixed and mobile devices for a short range. That ultra high frequency radio waves in the ISM band, like normally 2.40 to 2.48, and for forming a personal area network. So it is as the alternative to RS-232 data cables. It is alternative for RS-232 data cable, 10 meter to 100 meter, and that again that frequency can be up to 5.4 to 5.80, 5.95, up to 400 meter, that range that can be supported, more than a kilometer that can be supported. Bluetooth is normally managed, so every technology that will be managed by some of the authority, like Wi-Fi group, then there is IRDS standard, then there is some hyperlan, so that mobile standard. So that way Bluetooth is managed by Bluetooth special interest group, which has more than 35,000 members of company. IEEE standardized Bluetooth as IEEE 802.15.1, but no longer maintains the standard. Bluetooth SIG oversees development of the specification, manages and qualification program. So this is for SIG. And as far as its implementation is concerned, this is a short link radio technology, name after its after in the memory of that great king Denal Harald. So in the memory of that, so its nickname is Bluetooth. So it is initially deployed in a mobile, then it goes for a laptop and that ThinkPad and all those. It will be getting day by day more popular. So it is for smart home technology, and it will be getting more and more popular day by day. So it is a wire replacement communication protocol, primarily designed for low power consumption and short range based or low cost transceiver communication. So chips, those are incorporated in most of the electronic devices, and you can have a small your network formation. So this is for Bluetooth. So as far as this Bluetooth activity is concerned, it is a universal radio standard interface of ad hoc network that can be formed with the help of Bluetooth. Personal area network formation with the help of computer, handheld devices, PDA devices, so that can be possible. It's different, lots of applications those are available, like wireless control and communication between mobile phone and a hands-free headset, wireless control and communication between mobile phone and Bluetooth compatible car stereo system between the SIM card and the car phone, wireless communication between smart home and smart lock for unlocking doors, wireless control of communication with that Android and iOS devices. This is that headset is some of the time called as Bluetooth, wireless streaming, wireless internet access, networking that can be possible, transfer of files, contact detail, calendar appointment and reminder between devices with that object exchange protocol, sharing directory, replacement of wires interface RS-232, serial communication test equipment that can be possible, GPS receiver, medical equipment, barcode scanner that can be possible, for control where infrared was often used that can, so over there are possible. With the help of Bluetooth, a Bluetooth device means you can form a small network, you can form a great network. That small network is like with the 8 different Bluetooth devices, you can form a small network that is normally termed as piconet, and that piconet can be grouped in some higher section, so it can be termed as scatternet. So 256 devices that can communicate with each other. So normally this Bluetooth most of the time read under the head of 802.11 section, but it is not the case. So this is all about for Bluetooth story. Now, as far as Bluetooth is concerned, so it is voice. It is you responsible for voice packet data transmission more than 1 Mbps, 2.4 GHz ISM band, 2.480, 2.5.4, 5.8, 5.95, 433. So those are the different frequency bands those normally utilized in case of Bluetooth. So again, Gaussian frequency shift keying, GFSK modulation that will be enhance its security, frequency hopping. With the help of frequency hopping and anti-DD approach, you can transfer your information more secure and more secure way. And that hopping on the basis of PN code, so that is pseudo random code determined by the master, and that TDD for send and receive the data. So separation that will be incorporated. Voice link, synchronous connection oriented, forward error correction in case of frame loss that will be utilized. So forward error correction, error checking, error control, 64 kbps data rate that will be supported. Duplex link formation can be possible. Point to point connection, point to multi-point connection, circuit switch and packet switch network communication that will be supported by Bluetooth. So indirectly overall Bluetooth seems to be great player from this WLAN group. So 433.9 kbps and 723.2 kbps, that is symmetric and asymmetric data rate that normally supported by Bluetooth. So Bluetooth seems to be more promising member from the WLAN family because it provides security, it provides quality of service, and that your different application and its coverage is seems to be somewhat great and great. Day by day this seems to be improved. So you can have Bluetooth version 4.5, 5.5, then you can have more than that. So this is the way how this Bluetooth playing an important role for forming a small network. With a frequency hopping spectrum, you can have a formation of 79 channel. From that, one of the channels for the guard purpose, 78 channels those are normally utilized. Same with the DAAS, we can have 23 channel and more than that channel those are possible. So this is the way how this Bluetooth playing an important role. So this is all about for Bluetooth. If you have any question, you do reply me, you can ask me on my mail ID that will be given on last lecture of the course. Thank you for your cooperation. Hello, welcome again. So topic WiMAX, wireless broadband access, or you can say broadband wireless access. This is nothing but the replacement for last mile connectivity, like digital subscriber line. This WiMAX technology is a wireless broadband communication technology based around IEEE 802.16, provide high speed high speed data over a wide area. The letter WiMAX stands for Worldwide Interoperability for Microwave Access, and its technology for point-to multipoint wireless networking. WiMAX technology is able to meet the needs of a large variety of users, from those in a developed nation wanting to install a new high-speed data network, to rural areas that need fast access where wired solution may not be viable. So that is the story of why WiMAX getting popularity. So additionally, it is being used for mobile application, providing high-speed data to users on a move or in a pedestrian condition. The standard WiMAX technology is a standard for a wireless metropolitan area network that has been developed by working group number 16 of IEEE 802 standard. Point-to multipoint broadband. So in that way it will be growing up, and this WiMAX broadband technology come up with some great solution. It basically utilizes orthogonal frequency division multiplexing for as far as data transmission is concerned. So that orthogonal frequency division multiplexing, so you can have multiple carrier for the same signal, or that single carrier for multiple signals. That way it will be working. And on the other side, MIMO, multiple input multiple output, that will be supported. Use the multipath propagation using MIMO. So it will be it enables operation with a lower signal strength level and below that, and this will be getting more and more popular as far as networking is concerned, and as far as replacement for a hyperLAN or WLAN is concerned. So this seems to be somewhat overview for this WiMAX. Now, as far as this wireless broadband access or this multiple access is concerned, this WiMAX network operates similarly to a Wi-Fi connection, but with a few key differences. The system has two main components, WiMAX tower and WiMAX receiver. Like Wi-Fi, WiMAX can connect directly to the internet by sending a signal from WiMAX tower to the WiMAX enabled computer via wired connection. So this is how it will be connecting. Again, as far as Wi-Fi transmission is concerned, speed is up to 54 Mbps, but WiMAX can go for 70 Mbps. It can go for 70 Mbps. So it is somewhat great speed. Again, WiMAX spectrum, that connection for the network handling large interoperable network, that will be supported. That WiMAX is normally utilized in metropolitan area network. WiMAX ranges up to 90 kilometers, as on the reverse of this Wi-Fi. Wi-Fi is for 100 meter and all that. So this seems to be very effective compared with the earlier Wi-Fi. So WiMAX is alive and well, but currently living in a shadow of LTE, which is somewhat used in IoT, Internet of Things, or Industrial Internet of Things. So this seems to be more promising. This again, difference between WiMAX and 5G is the unified support for 5G. WiMAX had to compete against LTE and the weight of the 3GPP community, which is third generation partnership project for the third 3G. And its spectrum is 2.3 to 2.4 GHz, 2.5 to 2.7 GHz, and 3.4 to 3.6 GHz. That will be the story for the WiMAX. Again, 3 to 100 miles, 3 to 10 miles, that communication, that will be supported by this with the help of this one. And apart from that, with some added version, it can support data rate, some great data rate, and with some great mobility. Initially, while it is deploying, while it is developed, it is not supporting roaming and mobility. Roaming, as all of you somewhat literate people, you normally knowing roaming. As you are visiting in some another country or another state, you might be getting some extra penalty or extra charges. So that will be avoided by the help of this growing WiMAX. And again, that it will be using licensed band, some unlicensed band, peak rate more than 10 Mbps, different mobility that will be supported, 250 km per hour to up to 15 km, media independent handoff between Wi-Fi to WiMAX, Wi-Fi to wired, wired to Wi-Fi, and that Bluetooth. All those can be switching that can be supported. Then again, that physical MAC layer seems to be improved in case of WiMAX, because it can be accommodating traffic for the channel, traffic over the channel, or the channel contention that will be controlled by the help of WiMAX. Scheduling, different scheduling algorithms, those are incorporated. So non-interfering basic of communication that will be supported. TV broadcast a channel those normally utilized in case of WiMAX for its communication. So this is somewhat brief about WiMAX, how this WiMAX and who going to use this and how it will be utilized. Again, if you would like to check for WiMAX, it is created by WiMAX Forum in June 2001. So this is all about for WiMAX and its information. So anything, if you're expecting more, so you can do call me or ask me. Thank you for session. Hello friends. So today's topic, RFID, radio frequency identification. The main player from the application area, from the market, means for commodity service, for commercial service, for wholesale, for retail, all those market shops, malls mostly utilize this kind of story, RFID. Radio frequency identification uses electromagnetic field to automatically identify and tags attached to the object. An RFID system consists of an tiny radio transponder, a radio receiver, and a transmitter. Transponder, radio receiver, and transmitter. So transponder, which accept the signal, cut down noise, signal conditioning, amplify, encode, then data collection, processing, then again decode, demodulate, send it back to the different point. So that is the transponder. This transponder term we again come across in case of satellite communication. So when triggered by an electromagnetic interrogation pulse from a nearby RFID reader device, the tag transmit digital data, usually an identifying inventory number, back to the reader. So this is the working story of RFID tag. RFID tag are of two types, passive tag, active tag. So passive, energy from the RFID reader interrogating radio waves, and active, powered by battery, and thus can be read at a great range compared to the passive. RFID tag can be classified as small range, long range, small frequency, high frequency. So there are different variants for this. So RFID reader and tags, those are available. This tag can be plastic. It can be in a steel package, it can be in a normal paper like material. So this is somewhat how this RFID seems to be available. So there are fast track RFID, there can be some small range RFID. So initially this invented in the form of listening device, one of the Soviet person who invented this one. So which convert that signal in the electromagnetic pulse, and then it will be for the purpose of processing. So that is the tag. These RFID tags can be either battery assisted or independent. Read only, having a tags may either be read only, having a factory assigned serial number, and that is used as a key into a database for the record purpose. RFID reader. RFID classified by the type of tags and reader. There are three types: passive reader active tag, active reader passive tag, active reader active tag. Passive reader active tag, the system has a passive reader which only receive radio signal from an active tag. Then it can be adjusted about 0 to 600 meter, that particular application. Active reader passive tag, System has an active reader which transmits interrogator signal and also receives authentication replies from the passive tag. Active reader active tag. The system active tag activated with an interrogator signal from the active reader. A variation of this system could also be battery assisted tags. So this is somewhat brief about RFID tag. Band 120 to 150 kilohertz, 13.56 megahertz, 433 megahertz, 865 to 868 megahertz, 90 to 928 megahertz, 2450 to 5800 megahertz. Then microwave 3.1 to about 10 gigahertz, that is the frequency range for this. So this kind of tags normally utilized in animal identification, in memory card reader, in defense application, in Bluetooth, in some we read application for the commodity services and all that. So this is bulk reading that also is supported by these tags. Again, as far as the usage is concerned, this RFID tag, it variety of applications those are available. Access management, tracking of goods, then tracking of person and animals, toll collection, machine readable, travel document, smart dust, timing support event, billing. So all those applications those can be possible. Retail application, control application, promotion tracking. So based on the event, based on the trigger, we can have all this. So this RFID tag may be available in like e-passport and all those kind of story in case of tracking, in case of location, sharing purpose. So all those. So biomedical application those can be complied this RFID tag in most of the case, but the quality of that manufacturing or that chips seems to be somewhat very different than the normal. Universities, schools, and for vehicles, so we are using this RFID for toll collection. So this is somewhat brief about RFID. RFID transmission data rate is about 9.6 to 115 bits per second. Its identification number, serial number is about 48 bit, 64 kilobits to 1 Mbps, that data rate in that case for transmission ID. That transmission range already that up to hundreds of meter or more than that can be supported. Simultaneous detection up to that, like as already I said, group detection. 256 tags can be scanned, 4 tags per second, that can be the handling capacity per tags. Frequency range, ISM band ranges, those are given. Security based on the application, commodity, retail, wholesale, depend on the application, depend on the product, depend on the application area, depend on the coverage. So security seems to be varied. Tax, costly, it can be very cheap to up to costly, depend on biomedical application to the normal commodity or normal book tracking system. But in this case, connection setup time, it normally depend on the product and medium access scheme. Medium access, so medium have collision, medium have traffic, medium have some problem. So in all those, the 300 kilometer per hour, that speed can be supported by over the toll plaza. But one problem with the RFID, no QoS, a simple denial of service, those are supported by this RFID. So this is the somewhat the problem who pull RFID from that popular application, or it's getting more popularity. So that is the okay. This is little about RFID. Thank you. Hello, welcome. Topic is mobile communication from the group of wireless WAN. Mobile communication, the technology that allows to communicate with others different location without the use of physical connection. It is an electric field used for full duplex communication. So in this case, this particular communication term as cellular network or cellular communication. Cellular network or cellular communication. Cell phone can be termed as mobile. That mobile phone can be termed as cell phone. Cell phone use radio waves to communicate. Radio waves transport digitized voice or data in the form of oscillating electrical and magnetic field called EMF. Radio waves carries information and travel in the air at the speed of light. cell phone transfer radio waves in all direction, that can be with a omnidirectional antenna, or this with a directional antenna. You can have a microwave kind of communication with the help of this mobile communication or this cell phone. The different types of mobile communication system are a mobile two-way radio, public land radio, mobile telephone, amateur radio. Mobile two-way radio are one-to-many communication system that operate in half duplex mode, that is push to talk. So that is the normal story for this. Handheld device, normally your mobile handset normal term as mobile equipment. Inside that there is a SIM, so subscriber identity module. Some of the mobile phone those have SIM card, but some of those inbuilt SIM card, and that SIM card have all that subscriber information, internal information, its related information, all the detail of the particular fellow is available in mostly in that particular SIM. And this mobile communication, that will be help, or that will be mobile communication range can be extended with the help of relay element. This relay element in the form of like BSTN or in the form of BSC. So that trans receiver station, DTS network, you can have base station controller, you can have mobile switching center, then there can be gateway MSC. So there are multiple elements. So your mobile, your nearby tower is called base station, base BTS, base station trans receiver, and then thereafter there is a mobile switching center, that will be mostly that some group of antenna that with some high size. Normally that mobile switching center with some controllers unit that will be available with that. And then there is a gateway MSC that normally utilizes the backbone of internet infrastructure. So handheld relay element, PSTN network is normally your public land mile network. That PLMN is like normal telephony network. That normal telephony network is helping for transferring your call over the landline, or through the landline they can communicate for a longest distance through the wire or through the fiber optic cable. Gateway element can be your JMSC, and in this case you may have your mobile phone that will be connected by nearby PLMN, then there is a switching center, and then there is a cell site. So this can be called cellular. Why? Because entire globe that will be divided in the form of some cell structure, and each cell that have different frequency band. This different frequency group or a group of frequency, those are somewhat shared by the cell. Cell can be of 11 size cell, there can be 22 cell, or that again that hopping pattern or that frequency use scheme normally utilized in this case, in case of this mobile communication. With this as the term that mobile communication is going on, so it will be this mobile communication can be read in the form of generation. So it will be connected with the internet, or generation can be with the help of development in the system. So with the current development, as with the last decade, there is a second two generation. First generation mobile system is advanced mobile phone system from the North America. 350 that megahertz band that normally utilized in that case. But thereafter, and again that will be utilized that frequency division multiplexing with FM. So those are utilized at that time of AMPS. But thereafter, then TDMA, second generation mobile, that will be started, and then there is a 3G, then there is 4G, then there is 5G. But at the speed of this 2G, 3G, 4G, 5G is about like 2G, that will the speed 64 kbps, 3G with the high speed system with the speed of 8 Mbps, and then 4G with the LTE standard that 50 Mbps, and 5G is about 10 Gbps, that is the speed normally supported. Second generation mobile network is normally based on GSM. The radio signal used by the first generation network were analog, while second generation that will be utilized in digital, like TDMA architecture, TDMA structure. 2G capability were achieved by the allowing multiple users on a single channel via multiplexing. During 2G, cellular phone were used for data along with the voice. Some of the features from the 2G is a 64 kbps data speed, use of digital signal instead of analog, enable services such as SMS, MMS, provide better quality voice. It allows bandwidth 30 to 200 kilohertz for each channel. So channel can be divided like this. There are 25 megahertz channel spectrum that is available, and each will be divided in the in the size of 200 kilohertz. Third generation mobile system that will utilize CDMA. Then it is normally termed as Universal Mobile Telecommunication System, as it is a core network. Again, though that technology is somewhat very different, but backbone seems to be somewhat mostly fixed. Only that radio interface devices that seems to be modified or upgraded. 3G network combine aspects of 2G network with the technology and protocol to deliver a significantly faster rate. Then that again allows speed is about 14 Mbps. It uses wideband wireless network that increase clarity, operate at the range of 2100 MHz, and bandwidth is about 15 to 20 MHz. 3G that speeds up 2 Mbps for the mobility of 150 km per hour. That is the speed. Increased bandwidth, data rate, then large capacity of broadband access, so that will be supported. And again, in the same group there is the IMT 2000. IMT 2000, that International Telecommunication Union, that's published this standard, and in that case they are supporting data rate about 21.6 Mbps and for the high speed communication. Fourth generation mobile system that comes in a market, and that 3G and 4G, there is somewhat huge difference. The key technology that have made 4G possible are MIMO, as earlier we explained, OFDM, that is as earlier we explained. Then so thereafter 4G and LTE, those combinedly working, and those achieve some great speed, high capacity, low cost per bits, and it is of 20 Mbps, that is the speed. Ad hoc and multi-hop network also been supported. Global and scalable mobile network also supported with the in case of 4G. In case of 5G, that peak speed is about 10 gigabits per second. Average speed is 400 Mbps, and in case of 4G, the peak speed is 1 gigabits per second. Average speed is 50 Mbps. Again, 4G architecture is normally divided into part, that's user support plane and network support plane, and then its handling that will be monitor every time. Then in case of comparison, as far as comparison point is concerned, in case of this 3G, 4G or 5G, in 5G it uses rarely that use radio millimeter bands in the 30 GHz to 300 GHz. Testing of 5G range in millimeter that produce approximately 500 meter with the tower, that results approximately that better accuracy over 500 meter from the tower, using small cells with the deployment of 5G with a millimeter wave that provide the clarity. There is a different elements, that is the active antenna, then there is the network slicing, that is the somewhat terms that seems to be incorporated in case of 5G. So this 5G seems to be somewhat very much improved compared with the 4G, and that 3G is long apart from that. So as far as its discussion is concerned, that 2G, 3G and 4G, this 2G, it will be started in 1993, 3G 2001, 4G 2009 and 5G is 2008. And as underlying technology already known to you, that underlying that like GSM, WCDMA, CDMA, LT, WMAP, WiMAX, MIMO and that OFDM, all those millimeter waves. After that there is a access system or that access mechanism, TDMA, CDMA, then CDMA in case of 3G, WCDMA, 3CDMA, 4G, 5G, OFDMA, and that packet slicing and packet switching, those can be incorporated. Bandwidth in case of 2G is 25 MHz, 3G 25 MHz, 3G 400 hundreds of megahertz, and then 5G 30 GHz to 300 GHz. So in case of 2G, multimedia features, internet access, SIM introduction. In case of 3G, it is high security, international roaming is supported. In 4G, speed is high and high speed handoff, global mobility. And in case of 5G, extremely high speed and very low latency. So small cell to some like pico cell, micro cell, mega cell. Again, in case of 2G, voice call, short message. In case of 3G, video conferencing. In case of 4G high-speed application, mobile TV, wearable devices. In case of 5G, high-resolution video streaming, remote control, vehicles, and medical procedures. So this is somewhat brief about mobile communication. This is one of the crucial part of wireless network. So this seems to be considered very seriously if the you people are interested in having a career in case of mobile wireless network. Hello friends. The last topic from our course, satellite network, the main network from wireless group. As we are knowing, there are somewhat natural satellites, those are available. Those are sharing some information with us directly or indirectly in the form of some waves, but human unable to recognize what signal they are sending. So to resolve this and what actually that particular satellite or what particular information those are somewhat saying from the galaxy over the earth, that can be very well tracked with the help of this satellite network. Not only this one, but our normal communication, data communication seems to be improved with the help of inclusion of this satellite network. So there are natural elements for the satellite network, as it is one of the part of communicating network. So natural elements are like moon, sun. These are the natural elements of satellite. And again, we are knowing this communication is through the revolving or through the movement of all those stars here and there. And but we are unable to recognize, we are unable to catch that valuable information from all those. So we are using artificial elements in the form of satellite or that machine kind of element that will be in the space, and that helping or that will be working on behalf of all those natural elements and sharing some valuable information with the earth people, so that they are aware with the natural calamity or disaster. So this is some brief about how the satellite and what is the satellite. A satellite is an object that revolves around another object. For example, earth is a satellite, the sun, the moon is a satellite of earth. A communication satellite is a microwave repeater station in a space that is used for telecommunication, radio and television signal. A communication satellite processes the data coming from one earth station and it converts data into another form and send it on the second earth station. So that is normal story of that communication satellite. So the satellite work with the under the control of frequency. So there are two kind of frequency, uplink frequency and downlink frequency. The uplink frequency seems to be somewhat high band compared with the downlink frequency. Uplink is the frequency at which ground station is communicating with the satellite, and downlink the frequency from the satellite to the earth station, artificial satellite to the earth station. So that is the normal story of the satellite. Now how satellite work? Two stations on earth want to communicate through radio broadcast but are too far away to use conventional means. The two stations can use relay element for their communication. One earth station transmits the signal to the satellite. So that is the normal scheme, normal theory that will be utilized. So what are the advantages? The coverage of the satellite seems to be very high. Transmission cost is somewhat independent of the coverage. Higher bandwidth is possible as microwave high frequency, ultra high frequency band and microwave band that normally utilized for the purpose of satellite network. Again, whatever this satellite. So as we are knowing, there are only 3 satellites, those are monitoring entire globe, and there are 12 satellites, those are monitoring on behalf of 3 for monitoring entire sections of this globe or a world. So entire earth is divided in the form of 3 subsections, and then there are further 12 satellites those are monitoring. But the problem with this satellite is that launching seems to be somewhat costly, bandwidth gradually used up by some of other communication, and there is a high propagation delay for satellite system than the conventional system. So process of satellite communication begins at the earth station. Earth station means you can consider your home. Here an installation is designed to transmit and receive signal from the satellite in orbit around the earth. Earth station sends information to satellite in the form of high powered, high frequency signal. The satellite receives and retransmits the signal back to the earth, where they are received by the earth station in the coverage area. So there are some of the terms. Satellite footprint. The satellite footprint is the area which receives signal of useful strength from the satellite. There is another term that is somewhat called orbit, earth orbit. So this is in relation of a satellite when launched into space need to be placed in a certain orbit to provide a particular way for its revolution so as to maintain accessibility and serve its purpose, whether scientific, military or commercial application. So with respect to Earth, that maintenance or assign that particular position is called Earth orbit. So over where satellite revolve. The satellite in this orbit are Earth orbit satellite. Based on Earth orbit, the satellite can be divided in different sections. There is a geosynchronous Earth orbit, geostationary Earth orbit, medium Earth orbit, low Earth orbit. So they again revolve in in a polar direction, in an inclined direction, in circular direction. Again, normally the range of satellite placement is 5,000 to 15,000 kilometer, then about 20,000, then up to 36,000, over 36,000 kilometer. That is the placement range for that geo. So geosynchronous satellite orbit is not a geostationary orbit in case of geo, but in MEO normally example is GPS that utilizes this one, and LEO that normally utilize in normal operation, TV broadcast and all those communication, those with the help of that one. So this is all about for the satellite and satellite network. But one more, satellite contain one of the main element is called transponder, the element which I explained earlier in case of WiMAX. So transponder is the crucial element in case of satellite. So transponder element need to be somewhat reliable. If satellite need to return back to the earth, this transponder need to be works reliably. If by chance there is some failure in transponder, entire satellite system getting collapse. So as earlier we heard some of the news in satellite destruction. So that is in relation with the transponder. So there are thermistor, then there is a temperature sensor. Those are facing a problem, and then there is a issue with the satellite particular landing. So this is all about for a satellite network. Thanks for watching. Thanks for replying for this valuable course. Thank you all of you. Thank you. Hello. So again, myself Santosh Purkar. Contact number is displayed over here. Email address has been given. Again, I would like to thanks to all the participants who would like to catch all the details from my side. So the course was wireless network. Under this course, we are just coming across the term: what are the wireless network, what are its constraint, its application, its frequency range, and we started with the introduction of WLAN and then WWAN. WLAN, the IEEE standard, then Wi-Fi group, those are maintaining those, then it will be somewhat flexible. Then there is a IRDA group, seems to be require shielding from the another player from the WLAN, seems to be effective. Personal area network can be formed with the help of that. Then there is the hyperLAN, seems to be the improved LAN with a better data rate. Normally this kind of story is used in a HSPDA or in case of GPRS. So packet oriented data service that will be supported by this particular hyperLAN. HyperLAN available in 4.5 version. Then there is a Bluetooth IEEE 802.15.1. it is having personal area network there. Promising technology as compared to the IRDA, because it get popularity, electronic devices embedding and embedding technology getting boom. So this seems to be getting more and more popular. So this section seems to be getting more popular. So apart from that, Bluetooth, then there is the WiMAX replacement for DSL. It will be indirectly supporting for Wi-Fi and WiMAX, line of sight, non-line of sight, license, unlicensed. Then there is a handoff, mobility, all those being improved with the help of WiMAX 802.16e, then 802.20. So up to that version it will be improved. Then there is RFID, the commodity service main player from the commodity and commercial market. RFID getting more and more popularity in mall, in group, in the society, for parcel management, for parcel movement, for toll plaza. So in that case it will be getting improved. On the same platform there is a barcode scanner, that technology, light based technology getting also been improved, or it will be getting in a market. Thereafter wireless WAN from the large coverage group, secure group, high frequency group, license band group. So mobile communication, then there are different flavors of mobile communication. It is a cellular structure because cell architecture, cell normally in a hexagonal form. So that seems to be important in that case. So then there is satellite network, GEO, MEO, LEO, satellite content, satellite some basic terms, its frequency, then all that. So this is Ka, Ku, K band that is normally used in that particular satellite net. So this is somewhat brief about this particular course. Hello friends, hereafter I am planned to have one of the course on a wireless sensor network and ad hoc network. Wireless sensor or ad hoc network. After that I might be trying for another course, that routing algorithm, ad hoc routing algorithm. So I am planning for ad hoc routing algorithm course in future. I plan to have that paid course. So if you please have any question, any issue, any objection, you please do reply me. Thank you for watching, thank you for attending, thank you for checking. Thank you.